6277. What information is contained in a convective SIGMET in the conterminous United States? A. Moderate thunderstorms and surface winds greater than 40 knots. B. Tornadoes, embedded thunderstorms, and hail 3/4 inch or greater in diameter. C. Severe icing, severe turbulence, or widespread dust storms lowering visibility to less than 3 miles. The correct answer is B. A convective SIGMET in the conterminous United States contains information about tornadoes, embedded thunderstorms, and hail with a diameter of 3/4 inch or greater. Convective SIGMETs are advisories specifically issued for convective weather phenomena, which are associated with significant thunderstorm activity. The purpose of a convective SIGMET is to alert pilots about hazardous conditions in the atmosphere that could pose a threat to aviation safety. Within a convective SIGMET, the information provided will primarily focus on the presence of tornadoes, embedded thunderstorms, and hail with a diameter of 3/4 inch or greater. These are the specific convective weather elements that pilots need to be aware of to make informed decisions regarding their flight routes and to take necessary precautions. This information assists pilots in identifying and avoiding areas of significant convective weather activity during their flight planning and operations. 6277-1. Convective SIGMETs are issued for which weather conditions? A. Any thunderstorm with a severity level of VIP2 or more. B. Cumulonimbus clouds with tops above the tropopause and thunderstorms with half-an-inch hail or funnel clouds. C. Embedded thunderstorms, lines of thunderstorms, and thunderstorms with 3/4 inch hail or tornadoes. The correct answer is C. Convective SIGMETs are issued for embedded thunderstorms, lines of thunderstorms, and thunderstorms with 3/4 inch hail or tornadoes. These SIGMETs are specifically focused on significant convective weather conditions that have the potential to impact aviation safety. Embedded thunderstorms refer to thunderstorms that are embedded within a larger cloud mass and may not be easily distinguishable from the surrounding cloud cover. Lines of thunderstorms are a series of thunderstorms arranged in a line formation. Both embedded thunderstorms and lines of thunderstorms can pose significant hazards to aviation due to the potential for severe turbulence, strong winds, heavy precipitation, and other associated phenomena. In addition, convective SIGMETs also include information about thunderstorms with 3/4 inch hail or tornadoes. Hail of this size can cause damage to aircraft, and tornadoes are powerful rotating columns of air that pose a severe threat to aviation safety. By issuing convective SIGMETs, meteorological authorities provide timely information to pilots about these hazardous convective weather conditions. This allows pilots to make informed decisions and take appropriate actions to ensure the safety of their flights. 6275. What information would be covered in an AIRMET? A. Severe turbulence. B. Extensive mountain obscurement. C. Hail of 3/4 inch or greater diameter. The correct answer is B. AIRMETs, Airmen's Meteorological Information, provide information about significant weather phenomena that may affect the safety of aircraft operations but are of lower intensity or widespread nature compared to SIGMETs. AIRMETs are issued for 3 specific categories. AIRMET Sierra, IFR conditions. This AIRMET includes information about widespread instrument flight rules, IFR, conditions such as low ceilings, below 1,000 feet, and reduced visibility, below 3 miles, due to fog, mist, haze, or precipitation. AIRMET Tango, turbulence. This AIRMET covers moderate turbulence, greater than or equal to 4,000 feet per minute vertical velocity, and sustained surface winds of 30 knots or more. AIRMET Zulu, icing. This AIRMET provides information about areas of moderate icing and freezing levels, including freezing rain, mixed icing, and rime icing conditions. AIRMETs may include information about extensive mountain obscurement, which refers to significant cloud cover or weather phenomena that can obstruct or limit visibility in mountainous areas. 6281. On a surface analysis weather chart, isobars are usually spaced at intervals of A. 2 millibars, B. 4 millibars, C. 6 millibars. The correct answer is B. On a surface analysis weather chart, isobars are typically spaced at intervals of 4 millibars. Isobars play a crucial role in visualizing and understanding atmospheric pressure patterns across a given region. They are lines that connect points of equal atmospheric pressure, allowing meteorologists to identify areas of high and low pressure systems. By spacing the isobars at 4 millibar intervals, meteorologists achieve a balance between providing detailed information and maintaining clarity on the weather chart. The spacing represents the pressure gradient, which indicates the rate at which pressure changes over a given distance. With 4 millibar intervals, the pressure variations are depicted with sufficient resolution, allowing meteorologists to discern fine-scale pressure features. Isobars that are spaced closely together indicate steep pressure gradients, which often correspond to regions of strong winds and more pronounced weather systems. Conversely, wider spacing between isobars signifies gentler pressure gradients and more stable atmospheric conditions. This standardized spacing of 4 millibars on surface analysis weather charts facilitates the identification of key pressure features such as high-pressure systems, anticyclones, and low-pressure systems, depressions, or cyclones. These pressure patterns have a direct influence on weather conditions, wind flow, and the formation of weather fronts. In summary, the 4 millibar spacing between isobars on surface analysis weather charts allows meteorologists to accurately analyze pressure patterns, understand weather systems, and make informed predictions about local and regional weather conditions. 6282. The position of fronts and pressure systems, as of chart time, is best determined by referring to A. Surface analysis chart, B. Radar summary chart, C. Weather depiction chart. The correct answer is A. To determine the position of fronts and pressure systems as of the chart time, the best reference is a surface analysis chart. A surface analysis chart provides valuable information about atmospheric pressure patterns, the location of weather systems, and the position of fronts across a given region. By examining a surface analysis chart, meteorologists can identify and analyze various features such as high-pressure systems, anticyclones, low-pressure systems, depressions, or cyclones, and the boundaries between different air masses known as fronts. These fronts act as zones of contrast between air masses with different temperature, humidity, and wind characteristics. The surface analysis chart displays isobars, lines of equal pressure, along with other meteorological symbols and contour lines, representing weather phenomena and features. These charts are created by synthesizing data from surface observations, weather stations, weather balloons, and satellite imagery. Meteorologists use the information provided on the surface analysis chart to assess the current state of the atmosphere and make predictions about future weather conditions. By analyzing the position and movement of fronts and pressure systems, they can anticipate the development of weather patterns, such as the formation of thunderstorms, the track of a tropical cyclone, or the approach of a cold or warm front. Therefore, when determining the position of fronts and pressure systems as of the chart time, the surface analysis chart is the most suitable reference tool due to its comprehensive depiction of atmospheric conditions and weather features.